Okay, the last part of our chapter on mappings and functions is to do with transformations of functions. Now, there's nothing new in this. You've seen it at GCSE, you've seen it in Year 12. The only difference now is the functions you're going to be asked to transform might involve e to the x, ln x, mod functions, these sort of things. Let's have a look at our basics and remind ourselves how it goes. First example, we're going to have a quadratic equation. We want to rewrite it because it's no good to us when I've got x appearing twice in it. I want x appearing once, and then I want to be able to see what happens to the curve of y equals x squared to be transformed to get this one here. So step by step then. I want to be dealing with the 2x squared, so I'm going to write 2x squared minus 10x, and then plus 57 outside. Careful with the 2, double bracket it. I've got x minus 5 all squared, and then minus 25 to complete the square, and plus 57, and then sort out my constant. I've got minus 50 plus 57, which is plus 7. So I've got 3 extra values in here, and it's quite straightforward at this time to actually describe the transformations in the order, because it's what we're doing to x. Basically, it's BIDMAS. So I'm doing the bracket first, so I'm doing the transformation of the x minus 5. And remember, any transformation that takes place within the brackets changes the x and does the opposite of what you think. So this changes the x, but it doesn't go 5 backwards. It's a translation, so number 1, translation of plus 5, 0, so 5 along in the x-axis there. Then the next thing I'm doing is the 2, and because it's outside the bracket, it's a stretch scale factor equal to 2 parallel to the y axis, so it's parallel to the y axis, and then the plus 7 afterwards is a translation again, but it's outside the bracket, so it does exactly what it says, it adds 7 onto the y's. So it's a translation northern plus 7. So I do a translation first, so I take x squared, move it 5 along, and then parallel to the y-axis, stretch it all upwards and downwards as appropriate, in this case only upwards really, and then shove it up by plus 7, and there's my curve there. Okay, so it's just as we've done before, nothing different there at all. And as I said, example 2, doing the same thing, but our function is ln x. So describe the things that are going on to go y equals 3 plus 4 ln x. Well, the first thing I'm doing with the ln is times it by 4. Yet again, it's outside the bracket, so it changes the y's. So the first thing is a stretch. Scale factor equals 4 in the direction of the y-axis, parallel to the y-axis. There. And then the 3, yet again outside the bracket, so it's a translation again. And it does exactly what it says in the y direction there. Okay, and that's really it. The only other transformations you're going to see are reflections in the x-axis and the y-axis, and that's going to come up in this example here with minuses. When I've got the minus inside the bracket, f of minus x, that changes the x's, so that's a reflection in the y-axis. In this case, when it's minus e to the x, what will the minus do here? It'll change the y, so it's a reflection in the x-axis. But that will come in a moment. Y equals e to the x. You see, it doesn't really matter what the function is. We just apply it in exactly the same way. What happens in this transformation here? 2 and the 3, yet again, not bracketed. Remember that in this case, to be bracketed, it might be within the power there. That's where it's to be a hidden bracket in this case. But there's nothing in those. In that case there, so I've got y equals 2e to the x, so I'll do the 2 first, so that's the closest to the x there. So as before, it's a stretch first, parallel to the y-axis, in the y direction, and then 2, translation, 0 and plus 3, does exactly what it says there. For b, 5 minus e to the x, the first thing I'm doing with e to the x is the minus, and that's my reflection. So it's outside the bracket, so it changes the y's, so So it means that the y will become minus y. It's a reflection then in the x-axis. That's my thought process there. And then the 5, don't forget it's not minus 5, it's outside as well. So just as before, it's translation, 0.5. Nice and straightforward. A couple to do with sin x now. In this case here, y equals sin x, y equals sin 2x plus 1. Right, let's have a look what we're doing first. The first thing I'm doing to x is the 2x. And you've got to be aware of the fact that in reality we don't write them, it's hidden brackets. If I press on my calculator, sine, the first thing that the calculator does is put a bracket there. So we tend not to write it when we're dealing with functions like this, but it's there. So because it's 2x, what is the 2 doing then? It's multiplying the x, it's changing the x's, so we still call it a stretch, even though it's more of a concertina, because it's a scale factor in this case of 1 over 2, a half, in the direction of the x-axis, parallel to the x-axis. So it's a concertina effect there. And the plus 1 being outside, as before, is a translation. 0.1. Ooh, this one's interesting. Y equals sine bracket 2x minus 60. I've got to be quite careful about this. I think because I've got two things in the bracket here, I've got two things going on. I've got the 2x and the minus 60. So it involves, because the minus, a translation in the positive x direction, and because the 2, it's a concertina effect as well. Now, what I'm going to do, partly to convince myself, is consider a few of the points there and think what will happen to those here. So if I put in particular values there like this, if I want to consider what happens to this curve here, well, the curve is not going to go through the origin. When x is 0, I've got sine of minus 60, it's going to be crossing the y-axis somewhere down here, so it's going to cross the x-axis somewhere there. If I make the bracket equal to 0, it will cross at 30. I'll come back to that in a minute. Where will it top out? This one tops out at 90, the basic sine curve. If I make the bracket equal to 90, 2x equals 150, this one will top out at 75, so it's going to be doing that sort of thing here. So let's have a think what's happening. I've got to be quite careful, because if I consider doing it in what I would think is the obvious way to do it, i.e. do the 2 first because it's closer to the x and squish everything, then I would get a curve that will go from 0 to 90, 90 to 180 like that. And if I then moved it 60 up, that curve would cross at, instead of 0 and 90, it would cross at 60 and 150, whereas this one is crossing at 30, not 60. What it looks like it's doing then, I'm doing the minus 61 first. I'm going to take the sine curve and shove it up by 60 first, and then squish it by a factor of 2 afterwards. So the order is counterintuitive in this case. It's a translation of 60 degrees 0 plus 60, and then it's a stretch along the x-axis. So you would think, because the 2 is closer to the x, I'd do the 2 first, I would squish it first and then move it by 60 degrees. No, I'm actually doing the 60 degrees first, and then I'm doing the squishing afterwards. In the same way, if I was to rewrite this as sine of 2 lots of x minus 30, like that, yet again, you would think the 30 is close to the x, I'm doing the 30 first and the squishing afterwards. No, I'm actually doing it the other way around. I'm taking this curve, squishing it by a factor of 2 first, so instead of going from 0 to 90 to 180, we'll go from 0 to 45 to 90, and then shoving it up that way by 30 degrees, so it crosses 30 and tops at 75, and it will bottom out down there again at 120, like that. So it's counterintuitive. You would think you do the thing closest, when you've got more than one thing in the bracket, you do the thing closest to the x first, but no, you don't. You do the other one first, and then this one that's closest second. So that's something to be aware of, and that's obviously the particular type of question that's going to cause you most issues. So good luck with that.